Alright, welcome to the course. We're going to start with a brief map of the course, where I will show you what you're going to learn, and then we'll start writing code. A little more than half of the course consists of lectures that introduce you to the basics of object-oriented programming. And in the rest of the course, we will develop a project implementing everything that we have learned in a clean and systematic way. We will start by answering the questions like what is an object and what is object-oriented programming, what are its benefits and why is it so widely used. Then we will create our very first simple class and start building on it with each following lecture, learning new things on the way. Throughout the course, you will learn what is and how to use class to describe an object, namespace to structure the files in your project, constructor to give initial values to your objects, fields to describe your objects, properties to allow the outside world to access your fields, const and read-only constants and how we may find them useful in a class, static fields and static classes and their unique properties, and last but not least, enumerations to create a limited input. Then we will have our project called Warrior Wars. In this project, we are going to create two warriors that will have weapons and armors, and we will make them fight with each other until one of them dies. So lots of fun is coming your way. I hope that you will enjoy this short course, so let's just dive right into it. Alright, we finally got to the point where we're going to start talking about object-oriented programming. The most natural question that you may ask yourself at this point is, what is object-oriented programming? And the most obvious answer for that is that this is a kind of programming that depends on objects. The next more natural question would be at this point, what is an object? And the answer to this question is both very easy, and at the same time it's very hard to grasp in the beginning because it's something that is very abstract. For example, as you can see here, I have written a couple of examples of objects. Well, basically anything can be an object. The person can be an object, the car, the calculator, the glass, Facebook. Your fingers are objects. Everything is an object. Anything that can be described with a given set of properties is an object. So at this point you may ask yourself, what are the properties? The properties are the variables that describe a given object. For example, a person has a height, weight, hair color. These are some of the properties that can define a given person. The objects can have their own objects within them. For example, the car has an engine. The engine has its own properties. So you can see very quickly when we start digging deeper, we kind of create different layers of objects and of properties that can define one bigger object. So if our main object is the car, for example, that car has engine, it has tires, transmission, headlights. All of these are different objects that are within the car object. They in turn have their own objects. The headlight have light bulbs. The way that we describe these objects with these properties is by creating a class. The class is the thing that holds everything together. The class holds the properties of the given object. In some cases, it can also hold the objects that are within the object. So this is called an internal class. So a class can have a class inside the class. Like I said, a given object can have many layers of objects below it. We are no longer limited to the primitive data types. Classes allow us to create our own custom data types, which at their lowest level are described by primitive data types. You're probably asking yourself at this point, why do we have to bother with object-oriented programming? Well, the most obvious reason would be that it lets you organize your code much easier, much better. We are no longer limited only to our entry point class and our main method. We can create our own classes. Each class can have its own file. So this leads to much better organization of our code, of our files, of our projects, and this in turn leads us to much easier maintenance of the code. We can much easier extend it. In general, it's just much easier to be understood once you grasp the object-oriented concepts. For example, if you have a car and you want to change something on that car, for example, you want to do something on the engine that will make the car more powerful, you don't have to go and change your paint first and then do the engine. You just go ahead, open the engine, change the internals or whatever you want to do to the engine, you put it back together and your car is still running. Well, it may not be running, but the rest of the systems of the car are still going to run, those that are not dependent on the engine. So for example, your headlights are still going to work. They are not dependent on the engine, they are dependent on your battery, for example. So this is the main thing behind the object-oriented programming. It lets you maintain your code better, you can understand your code better, and you can much easier extend it if necessary. And it's always necessary to do this. How do we create a class? Well, we have to use the keyword class, of course, curly brackets, and the name of the class. It's very straightforward and very simple. After you define the class, you have to give it properties. The properties, like we said, are the set of variables that define your class. For example, if we have the class called point, the point can have x and y coordinates. After we have defined our class and its properties, we have to create an instance of that class. Or basically we just have to create that object. And let's go ahead and do this. So I'm going to open Visual Studio now. So let's create the class point. We create the class point outside of our class entry point. So we say class point, open curly brackets, and here we have to define the properties of that class. We have to use the public keyword in front of the variables, but don't worry about this yet. This is called an access modifier, and we will talk about them a bit later in the course. So public, then we specify the data type of the variable. In our case, we want to have integers, int x, and public int y. Now let's go back in our main method and create an instance of that class, an instance of that object. We start with the name of the class, point. We give it a name. So let's just also call it a point. And we say new point, open and close brackets. Now we have created a variable called point of data type point. So now we have our custom data type. When we say new points and brackets, this is the way of saying, hey Visual Studio, create a new object of data type point. Now we can give values to our properties. Let's go ahead and do this. When we say point dot, we get access to the variables that this object holds, to the properties of that object. In this case, the x and y. Now if I say dot x equals to 5, this is the way of giving some value to that property. If I say now console write line point.x, this will give me a 5. The same goes for dot y. We can give it another value, so we can say point y, run it, 5 and 3. Perfect. So this is how you can create one very basic class with a couple of properties, how you can define them and how you can use them. Let's extract our class into a separate file and see what exactly is a namespace. So right click on your project, select add and select class. Name the class, let's name it point. You should name the class file with the name of the class that it's going to contain. So let's add it and let's just copy and paste our class from here. Alright, let's save it. Perfect. So now we have our class in a separate file. You can see that it's still working. We still have access to that class, even that it's now in a separate file. What we are going to do now is we are going to create a new folder in our project, a new folder, and let's call it points and lines for example, just some arbitrary name, and move our class file inside that folder. We are now going to add a namespace for that class, and the namespace will have the name of the folder, points and lines, and we are going to move everything inside here. And now when we go back to our main class, we can no longer access the point file. If we want to access it, what we have to do is that we have to write using points and lines. So this is what the namespace is. The namespace lets you organize your class files. In a bigger project, you may have several different folders, each of them may have its own folder, and by adding a namespace to your classes, you can easily organize them and access them whenever you use their namespace. This is why when we try to use the console class, we have to write using system, because the console class is inside the system namespace. The system namespace has several different classes, one of which is the console class. The thread class that we use to create the pause in our code is located in system.threading, which means that threading is a namespace inside the system namespace, like this, using system. And when we press dot, so system is a namespace on its own, but when we press the dot, we get the sub namespaces inside the system namespace, and you can see that here we have many other namespaces. So basically this is all that the namespace is. It helps you organize your code better. That's all that the namespace does. The next thing that we need to learn in object-oriented programming is constructors. Every class has its own constructor. Even if you don't define one, it still has a constructor. This is why the class that we created earlier was working, because even if you don't specify a constructor, Visual Studio is automatically creating a default empty constructor for you. The constructor has the name of your class. It doesn't have any data type, and it may take or may not take arguments. This is up to you. It depends on the type of class that you're creating and what kind of initial values you need. So for example, here we have a class human. The class has height and weight, and whenever we create a human object, we want them to have height and weight. We don't want to have any humans that don't have height or weight. So we give these arguments to the constructor. After we give the arguments to the constructor, we have to assign them to the properties that we have. But if you notice here, they have the exact same naming. This has to change. We're going to use capital letters for our properties and small first letters for the arguments of our constructor. Now keep in mind that this is not the final way in which you are going to do it. We need to learn a few more things before I show you the final way, the proper way in which you need to create objects. So please bear with me for a couple of lectures. So capital letters, small letters. When we create the constructor, we are going to say new human. So we are going to say new human of, for example, height 180 and weight 70. This is how we are going to create it. When we do this, the height 180 will be passed here, and it will be assigned to height that has capital letter. So from here, it comes down here to here, and it goes back to this height. This is how it all looks. We have our class, we have its constructor, we have an instance of the class created with initial values given to the human class, and we use the height value of the human to print it on the console. So let's see this in action. I'm just going to use our point class and since there's no point in creating a new class, I'm just going to say public point. So I'm creating the constructor, no data type, it has the name of the class, open brackets, int x, integer y. So I want my point class to have both x and y defined at the time it was created. So I want to say big X equals to small x, big Y equals to small y, and we need to rename this to capital X and Y. When we go back to our class, we can see that now we have an error, and it says that there is no argument given that correspond to the required formal parameter x. If we delete and open the brackets again, we can see here that int x and int y are required. So let's just say 5, 3. We no longer need to define them outside of the class. To access them, we need to use the capital ones. And if we run the class, it's still going to work. Now, keep in mind that just like with normal methods, we can have multiple different constructors. So if you want to have the empty constructor, we can say public point and just leave it like that. So now we have two ways of creating a new point. As you can see here, we have one of two. The first doesn't require any arguments, and the second requires an x and y. So point 2 will work the same old way. This is almost our final way in which we are going to define our class. These variables here are normally called fields, and the fields normally are written in camel case, which means that they must start with a small letter, with a lowercase letter. In our case, this means that we need to name our x variable or field. We're going to talk a little bit later about fields. We need to make it again a lowercase x. So let's do this. And the problem that we now have here is that now we have two variables that have the exact same name. So we have a conflict of names. As you can see here, we even get a warning. So how do we fix this problem? The way to fix this problem is to use this keyword. This is a new keyword that we haven't seen so far, so you just have to write this dot, and when you write it, you can see that you have access to the variables of your class. Now our error is gone, and what we have here is this dot x equals to x. Now, what does this keyword actually do? It lets you use the fields, the variables, the methods, the properties, everything that you have in your class. It lets you use it inside your class. So we take this x from here, and this keyword says that we are pointing at the x of our class, and we're making it equal to the x from our constructor. So this keyword lets you distinguish between two different variables, fields, properties, methods, or whatever that have the exact same name. So it should be used every time you have a conflict of names. Again, this lets you distinguish which field or variable you are talking about. Now, if we also rename our y field, and if we use our shortcut to auto rename it everywhere where we have it to small y, you will see that it automatically renamed it to this dot y, and it also said here that one conflict will be resolved if we complete the renaming. So apply, and you can see that Visual Studio automatically did this for us. Now let's say that we have a third variable here, public int z, and if we give it a value of 5, and if we use this keyword now, you will see that Visual Studio says that the name can be simplified, and you can also see that this keyword is in a darker blue. So here lies the probably most important question in this lecture: when should you use this keyword? And there is no solid answer to that question. So the answer that I'm going to give you is the following. Whenever you have a name conflict, like here, you have a field that has the exact same name as an argument or another variable that you have inside your constructor or inside a method, you should always use the this keyword to distinguish between the two different variables. If you don't have a conflict of names, like we don't have it here, we can even say this.z equals to y, we still don't have a conflict of names, you can skip using the this keyword. It's optional in such case, which means it's entirely up to your preference if you are going to use the this keyword or not. It's entirely up to your preference or the accepted standards in the company that you work with. So again, use it when you have a conflict of names. Optionally use it when you don't have a conflict of names, but you are pointing at fields that are inside your class. And the optional use is dependent on your coding style or the accepted standards in your company. It's not wrong to not use it, and it's not wrong to use it. It's neutral, so it's entirely up to you. It provides no benefits, performance or otherwise. It's simply a syntactic sugar. Like I said in the previous video, these variables here are called fields. And generally fields are private, they are not public. So we're going to change this to private. And private is just another access modifier. Like I said, we are going to talk about access modifiers a bit later in the course. But basically what private means is that this variable can't be accessed from outside of the class. It's accessible only here inside the class. If we go back to our main method here, you will see that now we have an error and it says that the X variable is not accessible due to its protection level. Alright, if we can't access them like that, how can we access them? Well, the way to access them is to use properties. In order to create a property, you can use the shortcut that Visual Studio has, and this is prop tap tap, or you can just write it out manually. It's totally up to you. I like to use the shortcuts. The property usually has, most of the time, a public access modifier, a data type, which is the same as the data type of the field that you want to access, and the name of the property follows the name of the field. The difference is in the naming convention. The name of the property must be in Pascal case and the name of the field is in camel case. So if you want to use this property for the X variable, we're going to name it capital X. Now you can see here that we have something odd, something that we haven't seen yet, getters and setters. What the getters and setters are used for is to get and set a value. They can be expanded and they can have their own code. So let's just expand them really fast and give them their own curly brackets. What we have to do now is we need to write a piece of code that will set a value and another piece of code that will get a value. We said that the properties are used to access and modify the values of the fields, so we also need to use the field variables here. So how do we set a value for the X field? Well, we're going to say X equals, and here we're going to use another keyword we haven't seen yet, and this is the value keyword. So just write value. The value keyword will basically give you the value that you assign to the property. So when we go back here, you can see that now I can see only the X property that I just created and I can't see any of the fields. So if I use the capital X here and give it the value 5, the 5 is what we are going to get here. This value will get the value that is being assigned to the property. This is one part of the things that we have to do. Our setter is now completed. We have to handle the getter now. The getter needs to return the value of the field that we are using. So all we have to do is say return X. This is all that we need to do. And now when we use our, let me delete this. When we use our property, it will set and get the value for this field. We can't access the field directly, we are doing it through the property. So how does this help us in any way? There is no difference between just having the X field as a public, then to just get it and set it from the property. Two reasons. The first reason is that we may have other fields that don't need any properties. The fields that are only for internal use of the class and they need to stay private. We may, for example, have a private int xy sum field, for example, which is just going to calculate the sum, and then we're going to have a method that prints the sum on the console. This field does not need to be accessed from the outside world. We don't need to have a property for it because we're not going to assign anything to it. This is one of the reasons. The other reason is that here inside the curly brackets of the get and set methods, you can write code, not just x equals to value and return x, but you can write ifs, loops, anything that you want. Basically, this is the place where, if you need to, you can perform a validation. And we're going to see how to do this in the next lecture. Let's do a little bit of refactoring to our code. Let's rename our class to, let's say, a user. Let's call it user. And let's change the x variable to username. And we also need to rename our property to username with capital U. And let's rename the y variable to password. Let's also rename them here. So this must become username and this must become password. All right, this also needs to be password. All right, now let's go here. So let's delete all of that. And this is a user now. And let's change the data type here to a string. So this is a string now, string, and this is also a string. Let's keep the password as an integer, and we're going to use only numbers for the password. Like I said in the previous video, we can perform data validation with the properties. Let's first quickly create a property for our password and let's expand it. All right, return password equals value. Perfect. So how can we perform the validation? Let's say that we can assign a username only if the username length is between 4 and 10 characters. So we're going to say if value.length is more than 4 characters and value.length is less than 10 characters, we want to set the value to the username. This will be a valid username. If it's not, we want to say, oops, this is not a valid username. Please use an username with 4 to 10 characters. All right, perfect. Now, if we go back here, we are not going to give the usernames through the constructor. We're going to use the properties. If we say user.username equal to something that will be invalid, so let's say just AB, for example, let's run the code. And you can see that we get, oops, this is not a valid username. If we try to access the username and print it on the console, user.username, we're going to get nothing because we never got to this point and a value was not assigned to the username field. So when we return the username from the getter, there is nothing in the username. Let's give it a valid username now, ABCD. By the way, I just noticed that here it needs to be larger or equal to 4 and smaller or equal to 10, because if it's not, a 4 character username will not work. This way it will work. And now we can get the username. We can even make it a bit more interesting here, and we can say return the username is just like that. And if you do it, the username is ABCD. We can do the same thing for the password. So let's minimize our username, and we can say password is valid only if, actually I'm just going to copy it from here and I'm going to paste it. All right, just that we are not longer going to have the length because we only have numbers here. And now we also have a validation for the password. This is not a valid password. Please use a password between 4 and 10. So our password will simply be a number. We can perform the same operation for the password, equals to 2, and we will get, oops, this is not a valid password. You get the idea. We can have a much more complex logic here if it's really needed. So this is one of the simplest ways to use properties to perform some kind of validation and to hide your fields. The last interesting thing that we're going to learn about properties is that the properties are not required to have a getter and a setter at the same time. Basically, you can look at the getter as a read and at the setter as a write. So we can have either a read-write property, we can have a read-only property, and we can have a set-only property. So let's see how does it work. We are going to make the username to be a read-only property, and we're going to delete the set. And we're going to make the password to be only a set property, only a write property. When we do it like that, we can see that now we can no longer set a value to the username. It says cannot be assigned to, it is read only. And this is expected. So we're just going to delete it. Here we set a password. If we try to use it, user.password, we are also going to get an error, and it says that cannot be used in this context because it lacks the get accessor. Alright, so in these cases, right now in this case, our password property, our password field is completely hidden from the outside world. We can set it, but we can never read it. Quite the opposite with the username, we can read it, but we can't set it. So how are we going to set the username? Well, we are going to do it through the constructor. With the constructor, when we use it, we will be able to set a value to our hidden field, and then we can get it with the getOnly property. So let's go ahead and do this. I'm going to remove the password from here, and I'm also going to remove it from here, and we're going to include the username. Let's make it Vachev, and now we will have a set username. Let's try it out. The username is Vachev, and we have an invalid password because we are still using the 2, so let's make it a 5. Alright, but we can't read the password. User.password. We can't read it. So in some cases you're going to need to have a read only, a write only. It's very dependent on the project, and we're going to see a couple of more specific examples when we finish with the basics of object-oriented programming. The static variables, they do not need an instantiation of the class that you're working with, which means that they can be accessed without creating an instance of your class. So let's create such field and see how does it work. Let's create a field called ID. So we want to keep track of the instances of the classes that we have. So let's say public static integer, and let's just call it user.id. If I go back to my entry point class, and if I say user dot, you can see that now I can see the ID variable that we just created, and I can even call it. So I can say console write line of user.id, and I can print it on the console, and it returns a 0. What I can't do is that I can't say user.id. So the static variables can be accessed only from the specific class. They are not dependent on the instance of the class. So even if we don't have our class created here, we can still access user.id like that. Now, what we can do is we can increment the ID whenever we create a new instance of the user class. So here I can say ID++, and here I can also say ID++. If we go ahead and try it now, we will get user ID equal to 1. What is happening here is that when we create a new instance of the class, we are creating it, we are going inside this constructor, it's incrementing ID by 1, and now this ID will be 1 for all instances of the user class that we have. If we create a second class, so second user equals to new user, but we don't give it an argument, we should get, actually let's have the ID after both instantiations. So let's see, and you can see that now we have user ID of 1 when we create our first class, and now after we created our second user, we have user ID of 2. So every time you create a new instance of the class, this ID will get incremented. So why is this useful? It's useful because you can use a static field to share a variable between all instances of your class. So basically you can look at the static field as a field that is shared amongst all instances of your class, and each of these classes can change the value of that field. Each of them can access it, and each of them can change it. We have a static field here, but it increments with every instantiation of our class. And if we want to check the ID, so if for example we want to get an individual ID for every class that we have, we can't. All that we can get at this point is the current number of classes. So this shouldn't be ID, this should be current ID. So how do we keep track of the specific ID of the specific class? Well, very simple. We're just going to create another field, another ID field. So let's just create it. So public int ID, and we are going to set the ID to be equal to the current ID. We can do the same thing down here. So we can do it down here. Okay. And if we now say console write line user dot, we have another ID. If we remove the current ID from here and we say use second user dot ID, third user dot ID, and we have the current ID at the end. So user dot current ID. If we run it now, we can see that we have 1, 2, 3 for the separate IDs and 3 for the current ID. Just to show you, if we move them down here, so they are not called, the IDs are not called immediately after the instantiation of the class, we are still going to get the same result. We can keep track of the ID. Now, one problem that we have here is that we can modify this ID. So here we can say user.id equals to 100, and it's going to work. Of course, this shouldn't be the case, and we shouldn't be able to modify the ID. So in order to fix this, we can use constants, and we have two different kinds of constants. We have the const keyword and the read-only keyword. The difference between the two is that the const constant must be defined before you run your code, and the read-only constant should be defined after the code was executed and it can get its value somewhere down the line. Enough talking, let's see how does it work. Let's modify our ID to be a read-only constant. So public read-only integer of ID, and you can see here that now we get an error saying that we can no longer modify it here. And if you look closely, it will say that a read-only field cannot be assigned to, except in a constructor or variable initializer, which means that this ID now can only get its value from inside the constructor or a variable initializer. So let's delete it from here. If we run the code now, it's still going to work, but now we have a read-only field, a constant field. It gets its value when the class is initialized and it can never be changed after that. So with the static field, you keep track of the current ID of your class. With the read-only field, you are saving with the read-only field, you can give a specific ID to every class. And the convention for the constants is to use only capital letters. Actually, it's again different, again depending on your company, on your style, but normally constants have their names with all capital letters, and if you have more than one words in your constants, you separate them with underscore. So if this was the name of the cat, for example, this would be the correct way to write the name for the constant. But there are some companies that prefer to use the Pascal case for constants, just like with properties. I don't like it. Again, it's up to your personal preference or the standards in your company. I prefer to use the capital letters and underscores because this shows me immediately that I'm working with a constant and I don't mix it with a property, for example. Alright. The second type of constant that we have is the const constant, and this constant, public const int, for example, height, let's call it height, must get its value immediately when it's initialized. So we can't leave it like the read-only constant. You can see that the const field requires a value to be provided, which means that we must give it some value when we are creating the constant. So we can't have a constant without a value. This is the difference between the const and the read-only. The const must get its value at the moment you create this constant field, and read-only get its value somewhere down the line in your code. It can be different for every class, but this const here will be the same for all instances of your class. The constants are static by default, which means that if we go here and we say user dot, we can see only our ID constant, but we can't see the height constant. The way to access the height constant is just like with a static field. You need to use the specific class. This constant will be the same for all instances of your class. In this specific case, all of our users will have a height of 180. The next thing that we're going to learn is enumeration. The enumeration can be used to define a set of constants which can be used to limit some kind of options or variables. You just want to give a specific set of options to someone. For example, you can say, alright, you can either choose black or white, you can't choose red, yellow, or whatever. These are the only two options that you have. So the way that you create an enumeration is by creating a new class file. So new class, let's just call it race, for example. And here we are going to change the class to enum, just like that. And as you can see, it also changed its color, and we have seen something like that in the past. The console color, for example, we have a specific set of colors that we can use for our console, and they are controlled by enumeration. We're going to take a look at that in a second. Now, let's say that we are either Earthlings, so Earthlings, or a Martian. So, as you can see, all that I did here was that I just wrote two different words. These are the only two in our set of values, in our race enumeration. And when we use it, we are going to have only these two as an option. So let's go back here and say public race. So we created a new field with the data type race, which is the enumeration that we just created, and it has the name race. Now, when we go down in our constructor, we can say race equals to capital race dot, and here you can see that we have either Earthling or a Martian. So let's say that we are Martians. Now, this doesn't seem very useful just like that, but let's say that we want to have an if statement here, and we want to say if our race, if the race of the user that we are creating is a Martian, we want his height to be 100. So if race equals race.martian to equals, we want to say height. So let's change this to read only. So we're going to define it in the constructor. So we want to say height equals to 100, else if race equals to race.earthling, we want the height to be 180. In this way, we're using enumeration to check if our user matches some conditions, some predefined conditions. We can't give it any other race. So depending on the race, we can have only two options. We're going to give our user a different height. The way we are going to define the race in the first place is by simply giving it as an argument, so race of race, and this time we are going to use the this keyword because we are using the same name, so we have race here and race here. So this dot race equals to race, and we need to give it as an argument here, so race dot earthling. So the way that you use the values of your enumeration is by writing the name of the enumeration, dot, and then you have access to all of the values in your enumeration. You can store them in a field just like we did here. When you store them in the field, you can use that field to check it against the other values that you have. So now I created a user that has the race earthling. When the user is created, this race will now be equal to earthling. It will set its value back to our this.race, and here we are going to say if our race is equal to a Martian, we have a height of 100, and if our race is equal to earthling, we have a height of 180. Now here we also need to use the this keyword so that we can distinguish between the different races. Again, we are using the race of the class, not the race that was passed as an argument. So this race is the one that's up here, and this race is just the one that we're going to use it to set to our race variable. Like I said, we have seen this when we worked with the console. So if we say console foreground color equals to console color, you can see that this is an enumeration. This is an enumeration that holds the colors, and when we press the dot, we can see all of the colors that we have available. You can't just set some random color that you want. So basically this is what the enumeration is used for. It lets you predefine a set of values, and when you give them to someone to work with these values, you say, okay, you can have only these 2, 5 or 10 values, and you must use one of these values. You can't use any other. This very easily helps you to prevent mistakes. For example, if we wanted to do the same thing but we wanted to do it with a string, so we can have a race string like that, and if we wanted to check if this race is equal to Martian or an Earthling, so Earthling, it's still going to work, but what you have to do is that you have to manually write the word, the string. So if we just write it like that, Earthling, it's going to work perfectly. We're going to match this Earthling here and it's going to work. But imagine that you just missed a character. What is going to happen now? Well, nothing is going to happen because now you're not going to match any of these two cases. This is the problem that the enumeration is solving. We have seen static fields. We know that they can be used without the need to create an instance of the class. Likewise, we can have a static class. So let's go ahead and create such class, and we're going to call it utilities.cs. So this is going to be a static class. So just write static class utilities, static. Alright, the static class cannot have a constructor. I just tried to create a constructor and I have an error saying that static classes cannot have instance constructors. Right, which basically means that you cannot create a new instance of the class. So if you say utilities equal to new utilities, you cannot do this. So how do you use such class? Well, you use it without creating an instance of the class, just like with the static fields. They are not dependent on the instance of the class. Likewise, the static class is not dependent on an instance of the class, and basically it's a class that can be used to store helpful methods, for example, helpful actions. So what we're going to do now, we're going to create one such method. We're going to create a colorful WriteLine method. We have seen the colorful WriteLine method, nothing too complicated about it, and now we're going to place it inside this class. So we're just going to say public void colorful WriteLine, and you can see that your method also needs to have the static keyword. So public static void colorful WriteLine. Perfect. Now, if we go back here and if we say utilities dot, you can see that we have the colorful WriteLine method. The console class is a static class. It's used exactly the same way. So when you say console dot, you have access to some properties and methods, but you do not need to create an instance of the console class. So you have used a static class so many times and you didn't even know it. So let's say that we want to create a method that creates a colorful message. So we need to have the message and we need to have the color, console color. Alright, console color is missing. We need to add the system namespace. We want to say console.foreground color equals to the color. And we want to say console WriteLine message, and we want to reset the color after that. Reset color. Now we can go back here and we can say utilities dot colorful WriteLine, our message. Let's say that the message will be the name of our user, so user.username, and you want to print it in a console color in a red color. So if we run it, we have the username is Vachev in dark red color. So we just created a static class just like the console class with a colorful WriteLine. This is a custom WriteLine method that we just created, and we can use it pretty much the same way that we're using a console WriteLine. Just that now we'll have a colorful WriteLine. The good thing here is that you can use this class anywhere you want. If you want, you can say, you can create a method here, public void say my name. So this will be just one very simple method that is just going to say utilities. It's missing the intro to OOP namespace. So utilities dot colorful writeline, and here we're going to give it the name of our user. So we're going to say this username with the color dark green, for example. And I have a slight mistake here, so utilities. All right. If we go back here, if we delete this, and if we say user.say my name, it's still going to work the same way, but it's just much more easier to do it like that. Instead of having the same method, you can have this same method in all of your classes, but it's just too much writing for nothing. You can just have one class that holds all of your such methods for you, and you can call it anywhere without creating an instance. Just utilities, color writeline, and do what you have to do. Of course, you can use it for much more complicated things than just having a colorful writeline, but this is just one simple example of a static class. A side note here, the static class is the equivalent of the Singleton design pattern. For example, the Java language does not have a static class. If you want a static class in the Java language, you have to implement a design pattern called Singleton, and only after that you can use a static class. And even then, what you are going to need to write is utilities.getInstance, open close brackets, and then you're going to have access to the methods or properties that you just created. This keyword is not needed here. All right. So let's start creating our mini project where we are going to practice all of the things that we have learned so far. In this second part of the course, we are going to create a simple project in which we are going to practice everything that we have learned so far. By the end of the project, we are going to have a very simple game. As you can see, it's just about 15 rows inside our main method, but it will be using a class that we just created. This class is also using other classes. It has a couple of variables, it has a couple of constants. It will be a very, very interesting project. Now, if we go back here, you can see that all that this game does, it's not even a game for us, it's a game that the computer plays with itself, is making two warriors, a good guy and a bad guy, fight with each other until one of them is defeated. If we run the project, you can see that both warriors are attacking themselves, and we get the health of each warrior after every attack until one of them is defeated. So Joe is dead and Bob is victorious. The turn of who attacks is set by simply using a random number, so it's pretty random based, but this doesn't really matter, as the point here is just to practice writing code in object-oriented way and practice using classes, enumerations, properties, fields, and everything that we have talked about so far. So let's go ahead and start creating our game. So the first thing that we need to create for our warrior wars is, of course, a warrior. So right click on the project, select add, and select a class. So we're going to create a new class, and let's call it a warrior.cs. So this is our warrior class. Let's delete the usings here, we don't need them, and we're going to keep the namespace because now we know what is a namespace and we're going to use it. Alright, so what will be the fields of our warrior? What is it that can define a warrior? So the warrior has health, so private int health. The warrior has a name, so string name, and we are also going to have one boolean variable that is going to track if our warrior is dead or alive, because by the end of the battle one of the warriors is going to be dead. So private bool is alive. Alright, this is for our primitive data types. But a warrior also has a weapon and an armor. So we need to create a weapon data type and an armor data type. So let's first create our fields. So private weapon, and let's just call it a weapon. And as you can see, we have an error because we are missing a weapon data type. This data type doesn't exist, so we need to create our custom data type. And if you remember, in our first lecture we said that with classes we can create our own custom data types. So let's right click, add class, and call it a weapon.cs. delete this, and if we go back here, you can see that the error is gone and we have the weapon. Well, for the moment this weapon does absolutely nothing because we have nothing in the weapon class, but at least we got rid of the error and we're going to populate the class in a minute. So we say that we also have an armor, so we are going to create an armor class as well. So a quicker way to generate the class is if you click on show potential fixes or control dot, and you can select generate class armor in a new file. If we do this, you can see that armor class was immediately created in our project. The error is gone and now we have our armor class as well. Perfect. So what else does our warrior have? Our warrior will have a faction, so he will be either a good guy or a bad guy. For the faction, we're going to use an enumeration. So we're going to say private faction, and the name of the faction variable will be also faction. So we are missing the faction now. Well, we can't automatically generate an enumeration with the control dot, so we're going to create it on our own. So add new class, and we're going to call it faction.cs, and here we are going to rename class to enum. You can see that now it became lightly yellow. Alright, so we said that the possible enumerations for our faction will be a good guy or a bad guy. Perfect. Let's go back to our warrior. You can see that the faction is no longer in error, so we fixed that as well. And the last thing that we need is to define what will be the starting health for the good guy and for the bad guy. So we are going to have two different fields. So private int good guy starting health and private int bad guy starting health. Alright, perfect. With this we have all of the fields that we need for our warriors. Now, if you want, you can add as many fields, as many different fields as you want to practice. So for example, instead of having one warrior class, you can have two different classes, a bad guy class and a good guy class, and you can have a much more specific fields or properties, variables for the good guy and for the bad guy. But since the only difference that we're going to have here will be in the health, we are going to stick with the warrior class. And also for simplicity, there is nothing harder in creating a second class, but I just want to keep this short and tight, so this is the way that we're going to do it. The next thing that we're going to do is we're going to define the fields for our weapon and for our armor classes. So let's start with the weapon. What does the weapon have? The weapon has damage, so private int damage. And this is all that we're going to have for the weapon. If you want, you can create different types of weapons. You can create an enumeration that holds the different types of weapons, so you can have axes, daggers, swords, and you can have different damages for the different type of weapon. So this is all that we're going to have for now in the weapon class. Let's go in the armor class. By the way, this internal keyword, you can delete it. It was automatically generated because we automatically generated the armor class. We haven't spoken about access modifiers yet. Internal is one of the 4 access modifiers, but don't bother yourself for now with this. So our armor is going to have armor points. So private int armor points. And this is all that the armor is going to have. We have created all of our fields private. This means that we cannot access them outside of the class in which they are created. So we need to determine which of these fields we're going to need to access outside of their class. For example, we're going to need to access the isAlive field so that we can check if the current warrior is either dead or alive, but we should not be able to change it. This means that we have to create a getOnly property for the isAlive field. So prop bool isAlive minus the naming convention. The properties start with a capital letter in a Pascal case. Alright, and here we said that we need to have only a getter, like that. So return isAlive. Now when we use the warrior class outside in a different class, when we create an instance of the warrior class, we can see if the warrior is dead or alive. I don't think that most of the other fields we are going to need to use them outside of the class, so we are going to leave them like that for the moment. And let's go back to our weapon and armor classes. So we need to be able to, again, only read the damage of the weapon. We should not be able to change it because this will be cheating. So prop int damage, again, only get, like that, and return damage. The same goes for the armor. So armor points, prop int armor points, again, only get. Perfect. Armor points, perfect. Alright, now we have created our properties, at least the properties that we think that we are going to need. If we need another property in the future, we can very easily create a new one. These are the fields and the properties that we think we are going to need, and we're going to leave it like that for the moment. Let's also fix our namespaces. So let's create a new folder here, a new folder that will be called enum, and inside this folder we're going to place our enumerations. We have only one enumeration so far, but we're going to place it here nonetheless. And if you create other enumerations, you're going to place them inside this folder as well. Now, since you placed that file inside this folder, we need to modify its namespace. So the namespace will now be warriorwars.enum. Alright, and if we go back to our warrior class, we get an error because we are not using that newly created namespace. So using warriorwars.enum, and the error is fixed again. Alright, we are going to create another folder which we are going to call equipment, and here we are going to place our armor and weapon. If you have more than one weapon class, if you have several different weapon classes or several different armor classes, you can have a folder equipment, and inside that folder you can have folder armors and folder weapons, and they can hold the armors and the weapons separated. I hope that you can see how all of that helps us stay organized. If you don't, by the end of the project you will. So we need to modify our new namespaces now. So this will be equipment, and our weapon will also have the same namespace, like that. So here we should get an error again. Let's add the new namespace that we just created. Perfect. So we have sorted our fields, properties, namespaces. Now what we need to do is that we need to create our constructors. Let's start with our warrior. Let's create its constructor. CTOR. This is the shortcut for constructors. Tap, and we have a constructor. The first thing that we need to decide which of these fields will be defined by the outside world, meaning which of these fields can be defined when the warrior is created. And like always, we want to give as little access to the internals of the class as possible, so we are going to have only the name and the function created by the arguments of the constructor. So we're going to have a string name and function. Alright, now inside our constructor we're going to say this.name equals name. If you remember, the this keyword is used when we have variables with the same names. In this case we have an argument that has the name and the field that has the name. So we need to use the this keyword because it specifies and tells us that this name here that is right after the this keyword is the name that is inside the class, and the name that is by itself is the name that is from the constructor. We're going to do the same with the function. So function equals to function, small function. All right. Now we have a couple of other fields that we need to give them some kind of initial values. So let's start with the isAlive field. When a warrior is created, he is alive. So we are going to say isAlive equals to true. Again, note that I didn't use the this keyword here. You can use it, but if you use it, you see that it says that name can be simplified. So you can use it if it makes you feel more comfortable, but it's not necessary. It is necessary to use the this keyword only if you have overlapping names. So we have sorted 3 of our fields: the function, the name, and the isAlive. The rest of the fields, weapon, armor, and health, we are going to define them depending on the function of our warrior. So we're going to create a switch case here, and it is going to switch on the faction. So depending on the faction, we're going to have different values for weapon, armor, health, and so on. Enter, and if you press enter again, it's automatically going to generate our cases, because we can have only 2 cases with this faction. We have only a good guy or a bad guy. Alright, so for the good guy, we're going to give him a weapon. So weapon will be equal to new weapon, and armor equal to new armor. The same goes for the bad guy. So weapon equals to new weapon, and armor equals to new armor. The other thing that we need to define will be the health. So good guy will have health equal to good guy starting health, and the bad guy will have health equal to bad guy starting health. Now we have a couple of issues here, and these are that the starting healths are not defined, as well as the weapons and the armors. The weapons and the armors are currently the exact same for both kinds of warriors. So what we are going to do is we are going to fix the constructors of the weapons and the armors. So let's go inside the weapon and create its constructor. So here we are going to give it a faction. So again, it will be dependent on the faction, what kind of weapon we are going to have. And we are also going to create 2 new fields. Again, damage for the good guy and damage for the bad guy. So private int good guy damage, private int bad guy damage. And here we are going to say, again, switch on faction. And if we are a good guy, damage will be equal to good guy damage. And if we're a bad guy, damage will be equal to bad guy damage. We missed a semicolon here. We're going to do the exact same thing with the armor really quickly. Private int good guy armor, private int bad guy armor, and constructor. I'm just going a bit faster because I'm doing the same thing for the third time. Switch on faction, and good guy will have armor points equal to good guy armor, and bad guy, of course, armor points equal to bad guy armor. Perfect. Now, if we go back to our warrior class, we have an error here, because now our constructors require a faction. Our weapons and armor require the faction of the warrior. So we're going to pass the faction here, the faction argument. So this faction argument is going down here in this constructor. And we're also going to place it here, here, and here. Alright, so far so good. We have a warrior, it has its constructor, all of its fields get defined at some point. We also have weapons, armors, they also get defined at some point depending on the faction. All is good. The next thing that we need to do is that we need to sort out the health, the damage, and the armor. So how are we going to do this? You may have been wondering why did I leave the starting health for the good guy and the bad guy on top and not down here with the other fields. The reason I did this is because the starting health for the good guy and the bad guy are going to be constants. So private const int. We're going to create them constants, and we're doing this because we don't want to give out the control of the starting health to someone else. It will be a constant, it can't be any different than that. Of course, if you have some different kind of logic, if you want to create something different, feel free to do this. You can freestyle as much as you want when you're object-oriented programming, and freestyling is what will help you learn. I'm going to make them constants because I don't want them to be different, at least not in the beginning. Once we set one of the constant values that we have for the starting health to our health field, after that we are going to start working with the field itself, and then we are going to be able to modify them. But what we want to accomplish here is to have a specific initial value for the health, and we don't want to give the control for that to anyone else. Private const int, and we need to rename them like we said in one of the previous lectures. Constants must have only capital letters with underscores. So good guy starting health, and let's give it a starting health of 100. Let's do the same for the bad guy. Bad guy starting health equals to 100. We're going to have both of them have the same health. Again, feel free to modify this and make it in any way that you want it. So we have to do the same thing with the weapons and the armors. So private const int good guy damage and const int bad guy damage. So let's give it the same, let's give them the same damage, let's give them a 5. Alright, armor, we have to do exactly the same thing. Const int, and let's fix the names. Good guy armor equals to 5 again. Bad guy armor equals to 5. Alright, now one slight mistake that I just did is that I shouldn't have renamed them in this way that I just did. What I should have done is I should have used the control RR, because we are using these variables in our code. We are using them in the code, and they also need to be renamed. So control RR good guy armor. The same thing here, bad guy armor, and I did the same mistake here. So let me just quickly fix it. Alright, and with the warrior we did it here as well. Perfect. What's going to happen here is that when we create our warrior, we're going to get inside this constructor. Depending on the faction, we're going to get a different weapon and armor. In our case, they will be the same because we gave them the same values, but they will be different if you give them different values. When we get to the health again will be dependent on the faction, and we are going to get the health from this constant up here. So basically most of our starting conditions are constants. We have no control over them outside of our classes, and this is good because this way no one can mess around with your class. So we have constants. Another thing that we want to be a constant is the faction, but since we are defining the faction down here in the constructor, we want to have a read-only constant. And if you remember, so let me just rename this now, it must be a faction. So if you remember, and we no longer need this down here. So if you remember, what the read-only does, it's a constant that is defined at runtime. So this constant will be set when we create a warrior. So when we create the warrior, just a second. So when we create a warrior, we will give it a faction. This faction will go down here. It will be set to this big faction here, to the constant faction. And once it was set, it can never be changed. If we try to change it somewhere outside of the constructor, so if we say faction equals to faction of bad guy, we will get an error. And as you can see, it says a read-only field cannot be assigned to except in a constructor or a variable initializer. So this is how you can use the two different types of constants in two different cases. As you can see, they can be really helpful. Now, the last thing that we need to do is we need to make our warriors be able to attack another warrior, and we are going to do this with a method. So our class is now going to have a method. The last thing that we need to do to our warriors is that we need to make them being able to attack. We have created our warriors, we have created our weapons, armors, and everything in between. But we still have nothing in our main class, and our project is still not doing anything. So let's go ahead and create two warriors. So let's create the warrior good guy. So this will be the variable name for the warrior. Make it equal to new warrior of, now we have to give it a name, and let's call it Bob and give it the faction. Now you can see that we are missing the faction here, but it automatically suggests that the faction is inside the enum folder, and it is. So we are just going to include the using warriorwars.enum like that. So faction dot, here we can select one of the factions that we have, and since this is the good guy, we're going to select the good guy faction. Let's create also a bad guy. So bad guy equals to new warrior. Let's call him Joe. Faction dot bad guy. Perfect. If we choose one of these warriors, let's see what do we have available, and you can see that the only available property that we have is the isAlive property, since this is the only property that we made public. Now, what we need to do to our warriors is that we need to give them something to perform, some kind of action. So we're going to give them the ability to attack, and we're going to do this by creating a new method in our warrior class. So public void, it will be void since it's not going to return anything, and call it attack. Now for the arguments, this attack method is going to take only one argument, and this will be the enemy warrior. So we're going to pass the enemy warrior as an argument. So it's going to look like that. So good guy dot attack, open brackets, and here we're going to pass the bad guy. So good guy attacks bad guy. How are we going to do this? We are going to do this by giving it an argument of type warrior. So warrior bad guy, or let's call it enemy. It's not always the bad guy. For the bad guy, the good guy is the enemy, and for the good guy, the bad guy is the enemy. So we're just going to call it enemy, just like that. All right, now here it gets a bit tricky. Let me minimize these. We have a class warrior, and that class warrior has a method that takes another warrior as an argument. And there's nothing wrong with that. it's going to work perfectly, so don't let this confuse you in any way. You will see in a second how we're going to distinguish between the two warriors. So the first thing that we need to do is that we need to calculate the damage that the warrior is going to inflict on the enemy. So we're going to create a new variable here inside our attack method, so int damage, and you can make up any formula that you want for your damage calculation. My formula will be weapon dot damage. So we are taking the damage of the weapon, this weapon right here that our current warrior has. So this is the damage of the attacking warrior, and we are going to divide that damage by the armor points of the enemy, divided by enemy dot armor points. So as you can see, the difference here is pretty obvious. When we use enemy in front of the properties that we use in the fields, we are talking about the warrior that is being passed as an argument to that method. And when we don't use the enemy in front, we are talking about the current warrior, this warrior here. So this is how we are going to distinguish them. Now, after we have our damage calculated, we need to inflict it on the enemy. And we're going to do this by simply reducing the health of the enemy with the damage that we just calculated. So enemy.health equals enemy.health minus the damage. Or if you want to write it in a shorter way, you can just write it like that. It's exactly the same thing. Now that our warriors can attack each other, let's go and create our simple game loop. So we're going to create a while loop, and we are going to say if, and here we need a random number. So we are going to create a static variable up here. So static random rng equals new random, and include the using. All right, so if rng.next between 0 and 10 is smaller than 5, so we give it a 50% chance, the good guy is going to attack the bad guy. Else, if it's above 5, the bad guy is going to attack the good guy. Perfect. Now we need to give it a condition for our while loop. This condition is going to determine how long they are going to attack each other, and they are going to attack each other until the health of one of the warriors drops below 0. But we don't have access to the health field. So what we are going to do is that we are going to use the is alive, so good guy is alive, and while the bad guy is alive, they are going to attack each other. But we have nothing here, we have nothing that modifies our is alive property. So the way that we are going to do this is after each attack, we are going to check if the health of the enemy dropped below 0. So enemy.health, if it's less than or equal to 0, we're going to switch is alive to false. Actually, the small is alive. And we are going to say, so if one of the warriors became dead, we are going to say console write line enemy.name is dead and name is victorious. All right, and let's try and run our code now. So everything will happen really fast, and Bob is dead and Joe is victorious. Let's run it a couple of times. Bob is dead, Bob is dead, Bob is dead, and we can see that now after 5 attempts, Joe is dead and Bob was victorious. At this point our game is pretty much completed, but we're going to do a few more tweaks in the game itself so that we can practice a few other things and that we can make it a bit more pretty. At this point our game is pretty much completed, and what is left to do is to just add a few minor details. For example, what we are going to add now is we are going to print the result from the attack on the console. So here we are going to say else. So if the enemy is not dead after the attack, we want to print the results from the attack on the console. So we're going to say console write line. Actually, let's delete this system from here and let's fix it like that. Looks much better. So let's say console write line who attacked who. Name attacked the enemy warrior, which will be enemy.name. And now let's say how much damage was inflicted. So we're going to say damage was inflicted, remaining health is enemy.health. Alright, now let's try and run this again. Alright, it works, but the problem that we have here is that everything happens too fast. So let's add a small pause here, thread.sleep of 500 milliseconds. This should be enough. Alright, let's try it again. Alright. We can see who is attacking who. We're going to add the name of the warrior that is being attacked right after the one was inflicted, and we are also missing the damage word. So let's damage was inflicted to enemy.name. Alright, let's try it again. So Joe attacked Bob, 1 damage was inflicted to Joe, to Bob, remaining health. Let's add the name here as well. So let's do it like remaining health of enemy.name is enemy.health. Let's try it again. Alright, looks much better. Let's make it a bit faster. Like that. Yeah. So we can see that they are pretty evenly attacking each other. We can see that they have a very little difference in the health. So at this point Joe has 72, Bob has 65. And we are going to see who will win in a second. I'm going to reduce their health so that this can happen faster. Alright, so Bob is dead and Joe was victorious, and Joe has 7 health left. Alright, so let's reduce their health to 20 so that we can do this faster. 20, like that. And right, what we're going to do now is that we're going to print this message in red or green. Actually, we're going to make it into 2 separate messages so that we can have both of them with different colors. So we're going to say to keep this like that, and here we're going to add the second console write line. Alright, so if we try it again, they are killing each other. Alright, so Bob is dead, Joe is victorious. And now we are going to create another class, which will be a static class, and we are going to call it tools.cs. So we are going to use this class for some simple tasks, actions, something that we don't want to write all the time. For example, we don't want to write all the time console.foreground color equals to green color and then reset the color. So we're just going to create one method that is going to do all of that for us. So we're going to say public static void colorful write line, and we are going to give it string, the text that is going to be printed on the console, and console color as the color that we are going to use as a color for this message. So console.foreground color equals color, and here we are going to say console write line text, and then we're going to reset the color. Reset color. Alright, And now when we go back in our warrior class, we are going to substitute console.writeLine with the colorful writeLine that we just created. So we're going to say tools.colorful writeLine, and we also need to give it the color. So console color. So this is the part where the warrior is dead. So we're going to give it a red color. And here we are going to give it the green color. So tools.colorful writeLine console color.green. All right, let's try it again. And perfect, Bob is dead, Joe is victorious. So there it is, a simple usage of a static class. We can have a couple of other methods here. Just feel free to practice with anything that you may want to do. The remaining thing that we can do here is that we can extract this in a separate method that is going to be called, let's refactor it. Use the Ctrl+RM shortcut to extract this as a method. I'm going to use it from the menu because Ctrl+M is a reserved shortcut for my recording software. So I'm going to do it like that, and I'm going to call it attack result. All right, and finally our project is completed. Again, like I said, feel free to practice, to change things, to break things if you want. If you can't, find a way to break them and then to fix them. This is the only way to learn.